So not wasting any further time, it's already 5 minutes. We'll start our class. Let me just start the recording. So once again, good evening to everyone. Om has talked a lot about me. So basically, I'm a geophysicist by practice, a geologist and a geophysicist, graduate in geology, postgraduate in geophysics. So I can understand your pressure, what you're going through right now. A geologist being asked geophysical questions in a competitive exams. That's really tough, right? So I will not make this course really tough for you guys. Geophysics is a lot of about mathematics and physics with geology. So I'll design the course in such a manner that there will be less of mathematics and physics, but there will be more of geology. But having said that, you cannot run away from mathematics and physics when you talk about geophysics. But trust me, I'll make it very simple for you. Let me know when you can see my slides. I'm sharing my screen. Can you see? Okay, entire screen. No window. Okay. Can you see my screen? Okay, thank you, thank you, thank you, thank you. So today's class is about the introduction. I'll cover from what geophysics is, why geophysics, different modules in geophysics, their practical applications, their principles, and then we'll conclude with what we will be learning in the upcoming classes. So today's lecture, 1.5 hours, we'll be only speaking on the introductory part in a very, very generic manner. There will be no mathematical equations, there will be no physical concepts you will be introduced to, but this is a generic to build a generic perspective around why geophysics and how you can integrate or how you can uh, correlate with geology and how easy it is when you will start understanding and how easy the questions which you will be facing in your competitive exams will be for you. So I am developing this course in such a manner that it is more of on understanding and geophysics from a competitive exam point of view, so that you are well versed with answering the questions you'll be facing in GATE, NAT, GSI. GSI is a little bit elaborative, but surely for GATE and NAT. So over the course period, we will be talking, today we will be talking on the methodologies in geophysics from potential field, that is gravity, magnetic, then EM, electrical
Sorry
methods.
to interrupt, sir. Sorry, I'm
Yes,
really sorry.
yes,
There are
please.
little bit concerns from the students. Your screen is not visible. It's lagged.
Okay,
It's
okay,
stuck
okay,
somewhere.
okay. Let me reshare.
Can you
Let me
just
reshare.
reshare
Thank
the
you, thank
screen?
you.
Yeah. Okay. Right.
Okay. Entire screen. Share. So can you see my screen now? A quick thumbs up or a quick yes. Okay, thank you. So guys, when I'm presenting, I will be on presentation mode. So I may not be able to switch back to your questions as I'm only using a single screen today. So you can unmute yourself anytime, stop me in between, and I'll be really happy to answer your questions. Or if I get muted sometime or there is a lag in connection, there is a problem in the screen sharing. So just one more confirmation. Can you see a presentation mode now? Can you see the first slide, Introduction to Geophysics, in a presentation mode?
Yes, sir. It's visible. Right.
Okay, thank you, thank you. So as I was talking about in today's course, we'll be talking from the methods in geophysics, different methods, how the data processing goes like, and what it is in a very, very, very basic and generic manner, and what is then done after data processing, that is inversion of data, and where are the applications of geophysics in the field of mineral exploration, hydrogeology, engineering geology, oil and gas. And then we'll focus on how we will be engaging geophysics from an exam point of view, right? Then we'll be talking about how we'll address problem solving and practice geophysics in the upcoming classes, right? So I'm audible, very well audible, and my screen is visible. Let's move forward. A yes, a quick yes, and a thumbs up. Class, can you see me? Can you hear me? Okay, okay. So for my understanding, can you unmute yourself and speak? Do you have that privilege with you? Can you unmute yourself? Anyone? Tarun, Mani, anyone?
Is set.
Okay, okay, thank you. So I'll humbly request you when I'm presenting my screen, I'll not be able to see your all, right? I'm just using a single screen. So please unmute yourself and talk. Let's make it an interactive session. Okay? Guys, come on, be with me. Yes, let's say yes.
Yes, sir.
थैंक यू मजा नहीं आएगा यार ऐसे अकेले में बात करूंगा 1.5 घंटा यू गाइस विल बी बोर और आप लोग से ज्यादा आई गेट बोर ओके so learning objective from this course is make you all guys understand what geophysics is and its scope, the major branches in geophysics, methodology which is used for earth science, understanding the role of geophysics in mineral exploration, petroleum engineering, environment, and all of these. But our key focus will be on understanding the exam relevance, how we can learn geophysics from a geologist point of view, and how we will be able to address all the questions we'll be facing in the competitive exams. Okay, so in today's class, we'll set a foundation for the deep upcoming modules, just a preliminary or understanding point of view. So what geophysics is really about, right? So definition wise, geophysics is nothing but the application of the physical laws which are there in the Earth system, its progression, and then by applying all these laws to understand the Earth system, like what you guys do in geology, geochemistry. In geochemistry, you try to understand geology with respect to the chemical composition, like what is the composition of basalt, rhyolite, what is the composition of a sedimentary, why it is sedimentary, why it is metamorphic. So how you understand? You guys understand it by the physical properties of rock, the chemical properties of rock. So that in the same way, there is also one more vertical, that is the petrophysical properties or the physical properties of rock, where geophysics come in picture. It's a non-invasive method, and by using it, we try to understand what is there in the subsurface. The key idea is to understand the physical property variation by measuring the physical fields. We try to understand where are the anomalies or where are these an enormous physical property which is giving rise to any of a contrast what we see. So that is nothing but a change in physical property of the rock, as in how a metamorphic or greenstone belt is different than a blue cyst facies, green cyst and blue cyst. How you distinguish between them on the basis of the key minerals you find, on the basis of the chemical properties you see, on the basis of the settings they are in. In the same way, in geophysics, what we try to do is by understanding the physical properties, the rock properties, the contrast in the rock properties, we define them as a geophysical horizons. Right. From a qualitative nature, when I say a qualitative nature, that is more of to do with the data we acquired from field. Then there is a lot of processing of data in office. Then there is a lot of forward modeling, then inversion of data, and all of these is done to estimate the subsurface property. And by estimating the subsurface property, we try to understand what is the geology responsible for giving me all this response. Guys, are you with me? Tarun, anyone? Mani?
Yes, sir.
Thank you, thank you. So is my speed okay? Can you guys follow me? Am I too fast? Am I too slow?
Yes, sir, it's okay.
Okay. Anytime you guys have difficulty understanding any topic, pause me, ask questions. Why geophysics for geologists? So this came in my head when All of a sudden we saw seeing geophysics related questions in the competitive exams. uh, as geophysicist is asked to understand the geology, in the same way geologists are also expected to understand the physical properties of rock, and that's why geophysics becomes important for a geologist as well going forward when they will be stepping in professional fields. So from that perspective, from that point of view, sorry. So from that point of view, why you guys at all need to understand geophysics? यार ये तो एक different field है. We are good with our rocks, right? So because geophysics is a tool which will help at the end of the day to the geologist to explore new mineral potentials, maybe to find out a new discovery, maybe to find out a new problem lying there in the environment or solve a new problem. So when you guys step first, and any geoscientist steps first in the field, they see, let's say we are in a green field, right? So there will be a lot of soil cover. Let's say you are in Sahara Desert. There is nothing but sand and sand and sand everywhere. So how you guys are going to understand what is beneath the sand? That's why geophysics becomes important, and that's why understanding of geophysics is also critical for a geologist. And that's, I think, is the reason why you guys are seeing nowadays exams also focusing on questions which are also from geophysical point of from that perspective. So my slide is very generic and elaborative. You can go through it. So it's nothing but a non-destructive method for mapping underground covers, deep structures, inaccessible terrain. Like you are in Himalayas, you want to map out Himalayas, run a quick geophysical method, you'll be able to understand the broad geology. It's a cost-effective method. So airborne, ground-based magnetics, anything is of very low cost. You help the geologist at the end of the day to understand the drilling targets. It's multi-scale utility from engineering levels, from let's say a very local level to a very regional level, understanding the basin, tectonics and all this. It is applicable everywhere. So from the spectrum of, let's say you are characterizing a site which has to go for construction of dam, or there is a plot which has to go for further infrastructure development. So from that point of view, you can use geophysics. You can take geophysical application from that point of view till the tectonic evaluation of Earth, studying Earth, characterization, till that point. It improves safety, design. It is competitive from competitive exam point of view, typical questions and test concepts. So there will be questions in and around geophysics, which will test on how well versed you are with the concept of geophysics and how well you can solve the numerical problems you'll be facing. So there are a lot of branches in geophysics. When I was talking earlier, geophysics is a broader domain, and there are, if I have to characterize, there are basically three branches of geophysics. One which deals with the potential field, one which deals with the electrical field. When I say electrical, it includes all the properties or all the characteristics of electrical uh, methods, or the physics of electricity. Then there is this third, which deals with the seismic wave, which deals with the uh, seismic wave, propagation of seismic wave through the Earth structure. So point number one, you have gravity magnetics. It's a passive measurement like gravitational force. You all know that Earth has a gravitational force, a magnetic force. So this is nothing but already there is a physical contrast in Earth, or there is a source which is present within Earth, and you are using this physical property to characterize Earth. Then the second point is electromagnetic and electrical. So these are two different categories, where electrical deals with direct current and electromagnetic deals with electric and both magnetic characteristics of Earth. The physics of electromagnetic depends on electrical properties as well as magnetic properties. Seismic comes in picture. Seismic is a lot of time used in oil and gas exploration. Seismic deals with the propagation of seismic waves throughout the Earth. Then there is radiometric gamma ray spectrometry. We'll talk about this in more detail. There is GPR, which is used widely in near surface methods. There is borehole logging. There is a lot of chapter. We will be dealing with borehole logging. We'll be dealing with well logging concepts, application. Well, we'll be going to the further lecture courses. And the last point is the computational and the applied branch, where you have inversion modeling, machine learning, planetary geophysics, a lot of things, right? This we will not touch in detail, but this is also for you guys to understand in detail that geophysics cannot be only limited to the application part where it is mineral exploration or geophysical well logging or seismics for oil and gas, but it also has a wider area where it is used for developing new algorithms to process complex data. That is machine learning nowadays coming into the picture. That is planetary geoscience. Now people are going to spaces using geophysical technology towards even explore the outer space. So now when we have talked a lot, oh, okay, I forgot to hide this. Okay. So don't focus on the practice question now. We'll talk about it at the end of the slide. Somehow I missed to hide it. Okay. Earth as a physical system. So Earth you have now been understanding only from the geology point of view. Like rock property क्या रहता है, कौन-कौन से major rock रहते हैं, there is igneous, metamorphic, sedimentary. You are understanding from a different angle. Now try to understand the same Earth from a physical system point of view, right? So Earth is divided into different layers. There is crust, mantle, core. You guys know it very well. I don't have to go in detail. So what distinguishes crust from mantle and mantle from core is nothing but the physical contrast within them, the physical property or the nature of these different layers. Crust being a different chemical composition wise, a different characterization of crust can be done from a temperature and physical property or the pressure wise. Then you know what the metal composition is, what is the characteristic of mantle, and then core. So a fun fact is you guys will be aware about this, that the different layers of earth was explored using geophysics or used or understood using geophysics. It is nothing but the propagation of seismic waves which helped scientists to understand that these layers are there are different layers in earth. There is a core, there is a inner core, there is a outer core. So nothing but the physical system of earth can be distinguished or broadly characterized into two behaviors, that is the thermo and the mechanical behavior of the earth, which depends on the temperature, pressure, contrast, elasticity of the medium, the seismic wave property of the medium. So all these distinguishing features like temperature, pressure, then you have elasticity coming in, you have seismic coming in. So all the different properties, like in rocks, you have color, composition, characters, luster, cleavage, all these that becomes a defining factor or a characterizing factor for a rock. In the same way, the physics of the earth can be understood by these key physical properties: temperature, pressure, electrical contrast, the seismic velocity contrast, the electricity contrast, right? So in a way, when I have said all these things, earth is a very complex thing, right? The rocks are not that simple to be identified in field. It's very complex. It's very heterogeneous in nature. There is a lot of anisotropy within it. So all this anisotropy, all these heterogeneities affect the change in the physical contrast or the physical properties of rock. Rocks vary laterally as well as with depth. When we say when we move laterally or with depth, we see a lot of anisotropy coming in. There is, let's say you are in a metamorphic terrain, it's very difficult to unfold it. It's very difficult to even establish the geological history of that area. So you understand there is a lot of change within the subsurface. All this change also affect the physical properties of rock. And that's how these different properties, all these different methods help us to understand these medium. So I have, okay, this needs to be hidden. Okay. So that's a practice I do. I have on most of the slides, I have pasted a practice question kind of thing, which is a question for you guys to ask yourself within the slide. From this slide is here. I wanted to hide it and then show it to you at a later stage. But anyhow, what happens to the seismic velocity with increasing temperature? So that's the question you can be, or that's a broad question which you can see coming in GATE or coming in NET, coming in GSR. So nothing but they generally decrease with the velocity of seismic waves generally decreases with increasing temperature conditions. Guys, you are with me? Anyone confirm you are with me? Okay, okay. I'll ask you to unmute yourself, right? I can see Arshana, I can see Nishchit, I can see Tarun is there, Amrita is there. So I'll ask you guys to unmute yourself and talk also when we are on the slides, right?
Yes,
Okay,
sir.
I'll move forward. I'll move forward. Was that question helpful? That practical question? What happens to seismic velocity with increasing temperature? In the bracket, I have said the answer that they generally decrease. So that's the kind of questions or the broader framework you can, develop within your head, the kind of questions you'll be facing. So in the same way, you can also ask one more question to yourself that what happens to the seismic wave velocity with increasing pressure? Think about it. Next slide, the physical properties, we talked about it a lot, right? The physical properties and the relevant to the geophysical methods. So what are the major physical properties which govern this physical or the whole concept of geophysics? We'll talk about it one by one in a very, very generic manner. Then again, we'll be seeing in more detail. So the first property is the density. Okay. So by density, what is governed? Which geophysical method is governed by density? It's the magnetic anomaly. There's a pointer. Okay. It's the it gives rise to the change in the magnetic anomaly or the magnetic field, or sorry, gravitational field, and that causes a gravity anomaly. Then there is a second property, which is the magnetic susceptibility, and it goes with the remanence magnetism. That's a food for your thought. What is remanent magnetism? Go back, read about it. So change in magnetic susceptibility, it's a physical property of rock, will give rise to a magnetic anomaly, and the magnetic method in geophysics deals with its physical property. Then there is third, which is electrical resistivity. The vice versa of resistivity is conductivity. So in resistivity or the direct electrical property contrast, you have resistivity, you have IP. IP stands for induced polarization. Then there is EM. We talked about it in the earlier slide. It is electromagnetic field. So change in all these properties will give rise to a anomaly which is caused by electrical field, and the electrical chapters will be dealing with it in more detail in upcoming slides or upcoming lectures. We'll talk about this change in physical property. Understand when the upper two, the density and the magnetic susceptibility, are very generic. But from the third point, which is electrical property, it's very complex in nature. And around this only one physical property, there is 3 or 4 different phenomena which are happening. And that 3 or 4 different phenomena have given rise to different methods in geophysics. Right? We'll be dealing about it in more detail. A generic question or a generic sentence is strongly influenced. This is strongly influenced by the fluid content and the porosity of rock. The fourth property is the elastic moduli or the Young's moduli, the bulk moduli or the shear wave moduli. So these elastic property of rock gives rise to another domain of geophysics, which is nothing but the seismic methods, which deals with the propagation of seismic waves within the earth, the P waves, the S waves. The fifth property is the radiative activity of the rocks. Right. This I don't have to explain. You guys, are all aware about is what is the radioactivity of uranium, thorium, potassium. These are the key elements which give rise to radioactivity. The physical method or the geophysical method around this is the gamma ray spectrometry. This is used for lithology, highly used for lithological modeling, or sorry, understanding the surface lithology, alteration mapping. But this is very much limited to the surface. Like wherever you have the exposures, rock exposures, there only these are applicable. The final one is the porosity and the permeability and the fluid saturation. This is widely used in the hydrogeological characterization and the reservoir interpretation when we deal with oil and gas, when we deal with groundwater studies. These property contrast within the porosity, permeability, fluid saturation helps a lot in understanding the surface water saturation. Again, a practical question. This is funny. I wanted to hide this, but now you guys can see both the question and answer. If a body has a high magnetic susceptibility but low density contrast, what method will detect it better? So as I say, high magnetic susceptibility, which is relevant to the magnetic method, but a low density contrast. Give me an example of low density contrast rock. Anyone from students? Give me an example of low density contrast. Give me name of two rocks which have very similar densities. No one wants to speak? So how about dolomite and limestone? How about quartzite and let's say sandstone? So that's a low density contrast rock, right? The difference in density is very low. But high magnetic susceptibility. Give me an example of two rocks which have high magnetic susceptibility, like magnetite. Oh, sorry, magnetite will not be a rock, it's a mineral. Banded iron formations. Anyone? Give me two names. BIF sequence. So there is BHJ, BHQ, banded hematite, jasperite, and BHQ, banded quartz. BH, banded hematite, quartzite, right? So there the magnetic property or the magnetic method will be more helpful. So these kind of questions you can see in your exams. Next slide, geophysical data types. So when I have said all these, the density, magnetic susceptibility, electrical resistivity, elastic mobilize or the change in the elastic property of the rock, radioactivity, porosity, permeability, all these different physical properties are relevant to different geophysical methods. Now in the next slide, we will see which geophysical method stands for what property. So first, density. A change in density contrast will give rise to which method? The gravity field, the gravity method in geophysics. You are with me, students?
Yes, sir.
Okay, thank you, thank you. So gravitational method. So what happens in gravitational method? The change in the potential field. Oh, sorry. First of all, it is a potential field. Why I say potential field? Because this field is already there in nature. This field is present within Mother Earth, right? There's a pattern, yes. So you know that gravitational force is a characteristic of Earth. Magnetic field or the magnetic force is a characteristic of Earth. So in the same way, when we are dealing with potential field data, which is nothing but we are talking about the gravity anomaly map, which is the Boger anomaly map or a free air anomaly map. In magnetics, we are talking about the total magnetic field data or the reduced to pole maps. So in this slide, don't get confused. We are talking about कि कौन सा geophysical data type से किस तरह का data होता है, right? तो gravitational method रहेगा if it is gravitational method of exploration. Which kind of data we will be seeing? it's a Boger anomaly map, or it's a free air anomaly map. So that this is the type of data. Similarly, in magnetics, what you will be seeing, a total magnetic field intensity map, or a TMI image, or a reduced to pole. We'll talk about it. What is a reduced to pole when we will be talking, or in the coming lectures where we will be talking in more detail about magnetic methods of exploration. So इस तरह का data are characteristic to that particular method. Then you have electrical and EM data, where in electrical you see apparent resistivity map, IP chargeability maps for IP methods. So in electromagnetic, you see time domain electromagnetics. There is also something called as frequency domain electromagnetics. Right? We'll be seeing more details जब हम इस chapter के बारे में particularly बात करेंगे. So that's the kind of data type you have in electrical and electromagnetic. What is there in seismics? You have refractions, you have reflections. No, these are two different terminologies. A lot of chapter can be built around it. The time travel maps or the seismic horizons you'll be seeing will be either a refraction image or a reflection trace in the oil and gas exploration. The data type could be a short record. एक तरफ blast किए, wherever the seismic wave travels, you have a lot of receivers to acquire that data. You can see the short records. A CMP map, common method, CMP. What is the full form of CMP? Anyone? It's common method point gathering. That's a type of geophysical or seismic data acquisition method. Don't worry about this. We'll be talking more about in the relevant chapters. In the similar way, in radioactivity हम क्या देखते हैं? या तो potassium, या uranium, या तो thorium का concentration maps, right? So it would be K concentration map. It would be a uranium concentration map. It would be a thorium. Now today you can also see a ratio of this K by TH ratio, TH by uranium ratio maps, or it could be a ternary diagram where you have a triangle at one end, you have potassium enrichment, uranium enrichment, and thorium enrichment. Then there is well logging. So in well logging data, what are the kinds of data you see? Is a gamma log, is a density log, resistivity log, sonic log, overall geophysical yield, high resolution vertical profiles of the subsurface. So all these logs are of a very high contrast in the resolution. Remote sensing and interpretation will not talk about this, but it is believed that remote sensing is neither geology, neither geophysics, but geophysicists tend to include remote sensing in their chapter because geophysics is nothing but you are in a non-invasive way, you are trying to understand the earth. So remote sensing becomes a closely friend of geophysicist. So from remote sensing, you can drive the topography, multispectral imagery, thermal imageries. We will not touch upon remote sensing in this lecture module. Maybe it will be covered by other professors. A common practical questions. I'm sure you guys are just focusing on this, right? Practice question. Which data is best for a broad regional structural mapping? So that's the kind of questions you will expect in GATE or NET. The answer is regional magnetics and gravity. We will talk about this why regional magnetic and gravity and magnetic is helpful in characterization of regional structural maps. Keep this in mind when we will be going to these chapters. We'll be talking more about this. So when we have talked a lot about the physical property contrast, किस तरह का geophysical method रहता है, किस तरह का physical property contrast, किस तरह के geophysical method को rise करता है या evaluate करता है. Now there are different physical principles as well. Physical principle, when I say physics ka principles, right? So the first topic which we talked is the density variation. Density variation gives rise to the magnetic method. Yes, you guys are not with me. Gravity किसके वजह से है? Density contrast.
Yes.
मैं ही अकेले बोलूं क्या? You guys don't want to participate. I will not enjoy like this. You are 4 guys, मतलब 4 ही लोग हैं अपन यार, बात कर सकते. We can make it more interactive. Or I am too boring. Tarun, you are with me?
Yes, sir.
Thank you. Anyone else? Arshana?
Yes, sir.
Okay, thank you. Questions पूछो. हर एक स्लाइड के बाद में मैंने एक प्रैक्टिस क्वेश्चन दिया है. Are you enjoying that?
Yes, sir.
Yes, sir. बोलने से नहीं मजा आएगा यार. Let's make it more interactive, okay? So as I was talking, sorry, disappointed. Yes. Gravitational method. So when we say gravitational method, what is the physical principle behind gravitational method of geophysical prospecting? So gravitational method measures nothing, trust me, nothing but the change in the gravitational force of Earth. So gravity measures the gravitational acceleration due to Earth's mass distribution. Yes, the instrument which we use to measure this contrast is called relative magnetometers, right? No, relative gravimeters. Okay, be with me, guys. Relative gravimeters. Okay, and one more kind of gravimeters is there. One is relative, one is absolute. Keep this in mind. Okay, we will talk about this in more detail in gravitational method chapters. So, point number two, जो observed gravity है will be the observed gravity will be of two types. एक है जो रीजनल ग्रेविटेशनल फोर्स है उसका अर्थ का वहां पे, और दूसरा क्या होगा जो लोकल अनोमली है, और द लोकल मास ऑफ द अर्थ एट दैट प्लेस. ओके, सो इमेजिन करो कि हम लोग द ग्रेविटेशनल फोर्स ऑन अर्थ इज इक्वल एवरीवेयर, more or less equal. We will not get into the complications of gravitational force on pole and the gravitational pull on equator. So let's assume ये it's 9.8, right? 9.8 रहता है सब जगह पे. अगर हमने वहां पे एक हाई डेंसिटी मीडियम रख दिया, लेट्स से हम एक छोटे जगह पे हैं, let's say you guys are from Orissa, most of you guys are from Orissa, give me a hands up, give me a yes sir.
Yes, sir.
Okay, so let's say we are in Orissa. So Orissa is known for iron ore.
Yes, sir.
Iron ore is a dense medium, right? Density of iron ore is high. You guys have folded rocks. BIF वगैरह का रॉक पकड़ा रहेगा हाथ में, बहुत heavy feel होता है, right?
Yes, sir.
So when you have a high
Yes, sir.
density contrast material at a place, sorry, someone was saying something. कोई कुछ बोल रहा था? Should I continue?
Yes, sir. I just said yes, sir, when you spoke.
Okay. So वहां पे the Earth has its regional gravitational pull, which is 9.8, and there will be something which is caused by the local mass. Let's say it is banded hematite. Okay. So the density, or let's say Orissa is one famous for one more thing. It is famous for the Sukinda Valley, chromite.
Chromite deposit.
Ah, yes, Sukinda Valley. So chromite is a very dense medium or a dense rock. You all agree with me?
Yes, sir.
Am I right? Yes, thank you.
Yes, sir.
So let's say you are in Sukinda Valley. ठीक है, जहां पे अर्थ का gravitational field is 9.8. Let's assume it's 9.8. But as soon as you reach in Sukinda Valley, because of the deposition of chromite in that area, the local change in the gravitational pull of Earth has increased a little bit. When I say a little bit, we'll talk about all these. How much is little bit? How much change? Which instrument? What methodology? We'll talk about it when we will be dealing with this specific chapter on geophysical exploration by using gravitational method. तो थोड़ा सा बढ़ जाएगा because of presence of chromite, है ना? तो उस चेंज को, उस फैक्टर को हम लोग कैप्चर करके we can understand where this anomaly is coming from and what is causing this anomaly. Data acquire karke, we can go for the processing, compute the Boger anomaly. There is a lot of correction which is applied on the collected raw data. वो सारा process करने के बाद में you will get a gravity anomaly. These are the terminologies. I am just introducing you guys to the terminologies used in geophysics. Then you will get anomaly. This anomaly will be a gravity anomaly. Sorry. Then from that anomaly, you will try to identify which body is causing this anomaly. It could be many bodies, it can be produced by a similar body somewhere else. Then the strength. The next factor is ये anomaly तो अभी आ गया, but what is the strength of this anomaly? In Sukindha Valley, it will be very high. Let's say you go to Kadapa, okay, a sedimentary basin, a proterozoic basin, where you have all the sedimentary rocks, metasedimentary rocks, right? Where the strength or the change in gravitational pull is not that high. So the strength or the sensitivity or the variation of density at a larger scale, the contrast in the change in density will give you a better understanding of the anomalies. Gravitational pull at different locations will make you understand what is there below subsurface. So this data can be acquired either airborne, it is marine as well as, sorry, I forgot to include it. It can be airborne, it can be ground-based survey. It's a cost-effective method for a regional exploration. Also, it is marine. Okay, marine gravity survey is also there. A few of the limitations of this method. This is of low resolution for small and near surface bodies. Okay, and strong dependent on the accurate terrain and high corrections. So it is very sensitive. One of the thing is it's very sensitive to the terrain and it is very sensitive to the height corrections, right? And it is of low resolution for small and near surface bodies. When I say near surface and small bodies, let's say एक 4x4 square kilometer का area है जहाँ पे you have some local change in the rock property, okay, but using gravity maybe you will not be able to resolve that. But at the same time पूरा इंडिया का gravity survey अगर कर रहे हैं तो you will be able to understand the basic regions in the earth's craton. कहाँ पे आर्कियन टाइप ऑफ रॉक है, कहाँ पे कांटेक्ट है धारवाड़ का प्रोटरोजिक बेसिन से, where you are seeing a deep gravitational pull, where you are seeing a local pull. A practice question: why do we apply Boger correction? Go back to your notebooks if you have, or we will talk about it, which are the corrections which we apply. Note this: we apply Boger correction to remove the topography and the height effect and isolate the subsurface density contrast. Next slide. When we have talked about a lot on the principles, we let's say go into the interpretation and example point. एक बार data acquire कर लिया, then what we do is we do modeling. So these are nothing but the terminologies I am introducing. So step by step we will go into more details. Modeling करते हैं. Modeling मतलब जो data हमने लिया है उससे we try to generate a geologically meaningful subsurface model. Okay. So we take simple slab, cylinder, sphere kind of object. We do forward modeling, inversion hota hai to understand and estimate the density distribution. Use cases, maybe I'll share the slide. You can go through it in more detail. This is a very generic questions. I think I have no, okay, not here. But use cases of gravitational method. It is used for basin depth estimation, delineation of granitoids intrusion, iron ore bodies, kimberlite detection of regional signatures. जो भी regional signatures है उसके लिए ये एक point है. Note this down, the kimberlite detection. ये question आया भी हुआ है past में, if I remember well, कि which of the method in geophysics can be used for kimberlite detection, kimberlite pipe detection. Try to bring in your geology concept or the geology in it and understand the kimberlite, why kimberlite can be explored using geophysics. Last is the integration, right? Combining seismic and gravity together and magnetic together will reduce the ambiguity in the signatures which we are seeing. The practical tips. Practical tips is nothing but, let's say, the precision. As I say, it is sensitive to the height. The precision in elevation control, terrain correction accuracy, station spacing influences रेजोल्यूशन। सो ये सारा जो चीज है प्रैक्टिकली जब डेटा एक्विजिशन हो रहा होगा, प्रोसेसिंग हो रहा होगा, तो ये these are the key things which will affect the gravitational method. Practice question again, my favorite section. What two methods help resolve depth versus density ambiguity in gravity? I will leave this to you guys. Maybe when I'll be sharing the presentation, you can understand in more detail. ग्रेविटी हो गया, मैग्नेटिक मेथड का प्रिंसिपल क्या है? नथिंग, अर्थ का एक मैग्नेटिक फील्ड है, यू ऑल आर अवेयर. नाउ मैग्नेटिक फील्ड इज मोर सेंसिटिव, इट इज आल्सो अ पोटेंशियल फील्ड बट इट इज मोर सेंसिटिव देन द ग्रेविटी फील्ड, राइट? So the measuring the Earth's magnetic field intensity and the anomalies which is causing that in a local area can help us to understand the physical property or the change in the physical property and eventually help us in mapping that area. Then ethological mapping, structural mapping. एक तो चीज है कि जो अर्थ का मैग्नेटिक फील्ड है आज में उसके वजह से. द सेकेंड थिंग विच इज ऑल्सो इम्पोर्टेंट इज द इंड्यूस्ड मैग्नेटिज्म, ठीक है, विच डिपेंड्स ऑन द मैग्नेटिक ससेप्टेबिलिटी ऑफ द अर्थ्स फील्ड. ओके, and there is another second which is called the remanent magnetism, which depends on the history of rock formation, right? So these are two different things. One is the induced magnetism and one is the remanent magnetism. Note this down, understand, try to, maybe when you'll be sitting back and studying, try to understand the difference between what is induced magnetism and what is the remanent magnetism. This is vector in nature. When I was talking about gravity, I never told about we never talked on the scalar and the vector nature. Magnetic is a vector field. When I say vector, means it has a direction, the field has a direction to it and a value to it or a intensity to it. Whereas gravity में क्या होता है, gravitational force जो है अर्थ का सब जगह से vertical है अर्थ के ऊपर, but magnetic field, it is vertical on the poles and horizontal on the equators. So that's why at all the locations the direction of magnetic field changes. That's why it is vector in nature. The field direction matters. So that's why if the field direction matters, the same property on equator will look different when it is on pole. Okay, हम लोग ये सारा चीज के बारे में अच्छे से डिटेल में पढ़ेंगे. I'm just introducing you guys to these concepts. So because of this directional change in the nature of the magnetic field, it gives rise to a lot of correction in magnetic field data. There is RTP reduced to pole. There is IGRF correction, which is International Georeference Field. ठीक है, ये नथिंग बट इट इज अ मॉडल ऑफ अर्थ. पूरा अर्थ का एक मॉडल है कि अर्थ का मैग्नेटिज्म कहाँ पे क्या होना चाहिए विथ रिस्पेक्ट टू टूडेज डिक्लिनेशन एंड इंक्लिनेशन. सो ये सारा प्रोसेस के बाद में क्या करते हैं हम लोग, वी ट्राई टू प्लेस द एनोमली विथ रिस्पेक्ट टू इट्स ओरिजिनल causative location. We'll come to it in more detail. Instrumentations or the instruments which are used in magnetic method are one of the few names here, the proton precision optically pumped magnetometer platforms. This can be airborne, ground based or marine. Remember I also said gravity can also be nowadays marine based. Okay, or even these two methods are even satellite based. Will not go into that heterogeneity. Practical questions. Why does remanent magnetism complicates magnetic interpretation? So because its direction may differ from present Earth magnetic field and produce misleading anomaly shape. So if the anomaly shape is misleading, the interpretation will go wrong and eventually the exploration program will fail because the identified anomaly is of different shape and is of different location. It is not occurring where it should be. We'll go into more detail. जैसे ग्रेविटी का इंटरप्रिटेशन और एप्लीकेशन देखा था, वैसे ही मैग्नेटिक का इंटरप्रिटेशन और एप्लीकेशन. इंटरप्रिटेशन बेसिकली नथिंग बट इट विल बी यूजफुल फॉर mapping of dike, contact horizon, ultramafic bodies like nickel, chrome, then iron ore, structural mapping. Processing में जैसे gravity में हमने देखा था, there is lot of correction, terrain correction, free air correction, Boger anomaly. इसी तरह magnetic में processing में we see diurnal correction, IGRF removal, There are a lot of filters which are applied to smoothen the data. There is RTP reduced to bold. Then there is derivative maps, analytical signal, and localization of edges. Is ये सारा process करके we can identify that. जैसे ग्रेविटी का यूनिक लिमिटेशंस देखा था, वैसे ही मैग्नेटिक में इट्स, guys, you are with me?
Sir, what
sir.
is IGRF removal?
IGRF stands for International Georeference Field. It is nothing but पूरा अर्थ का एक मॉडल बनाया गया है, because the magnetism of earth keeps changing. राइट, सॉलिड अर्थ का जियोलॉजी का क्लास में पढ़े होंगे कि पोलार वॉन्डर होता है, और हिस्टोरिकल पोल को हम लोग ट्रेस करके वी कैन नो कि पोल का लोकेशन क्या था हिस्ट्री में। इसी तरह से आज के डेट में जो पोल है, हमारे नॉर्थ और साउथ मैग्नेटिक पोल्स आर कोइंसिडेंट विद आवर ज्योग्राफिकल नॉर्थ एंड साउथ पोल, राइट? So with history or with time, the gravitational field of Earth keeps changing. So आज के डेट में, let's say 100 years down the line, वो सेम नहीं था, बट आज के लिए वो एक कुछ है कांस्टेंट with respect to the local field, ठीक है? तो उस चीज को, मतलब जैसे अर्थ का ग्रेविटी 9.8 होता है सब जगह, राइट? एक होमोजेनियस मैं आपको बता रहा हूँ, इट्स नॉट 9.8 एवरीवेयर। इसी तरह से अर्थ का भी मैग्नेटिज्म है हर लोकेशन पे। So on equator it is close to 36,000 nanotesla. On poles it is close to 60,000 nanotesla. So this variation, अब मैं कहाँ पे सर्वे कर रहा हूँ, वहां पे रीजनल मैग्नेटिज्म क्या है, मुझे कैसे पता चलेगा? So this is a generic model known as IGRF model. Year on year there are institute which keeps this changing and updating. So वहां का local field जो regional field होगा उससे डिफरेंट होगा, तो रीजनल फील्ड रिमूव करके वी कैन नो द लोकल फील्ड, राइट? सो वो रिमूव करना बहुत इंपॉर्टेंट है, हम इसके बारे में और देखेंगे और जानेंगे, बट एज ऑफ नाउ यू अंडरस्टैंड दिस इज ए ग्लोबल अर्थ मैग्नेटिक मॉडल टू अंडरस्टैंड द रीजनल मैग्नेटिक फील्ड ऑफ अर्थ एट एनी पॉइंट ऑन अर्थ। ओके, is your doubt clear? I will repeat once again. It is a global Earth model to understand the change of magnetic field on Earth, the regional magnetic field on Earth at any point on Earth. Okay, मैं आपको एक मॉडल दिखाऊंगा अभी when we will be dealing with the magnetic chapter. Let's move forward. Should I move forward? Quick yes. You are with me, friends?
Yes, sir.
Yes, sir.
Thank you. प्रैक्टिकल क्वेश्चन, हाउ डज ये प्रैक्टिस क्वेश्चन जो है ना, ये मैंने आपके लिए डाला है, खाली और खाली आपके लिए। यू बेटर टेक अ नोट ऑफ दिस। मैं डोंट वरी अबाउट नोट्स, मैं ये सारा प्रेजेंटेशन आपके साथ शेयर करूंगा। तो दिस प्रैक्टिस क्वेश्चन इज नथिंग बट कि किस तरह का क्वेश्चन आप लोग और किस तरह का कॉन्सेप्ट से रिलेटेड क्वेश्चंस यू कैन फेस इन योर कॉम्पिटिटिव एग्जाम, गेट हो, नेट हो, जीएसआई। So this practice question on this slide is how does RTP help in magnetic anomaly at lower latitude? Bracket में इसका आंसर है it responds, it repositions anomaly approximately above or above source since inclination effects are corrected. So this is a food for you. एक तरह का thought है which I want to build in your head when you will be talking or when we will be dealing on these chapters. You keep this in mind. Let's move forward. So we saw gravity, we saw magnetic, now इलेक्ट्रिकल का बारी है। तो इलेक्ट्रिकल मेथड बहुत कॉम्प्लिकेटेड है, बहुत कॉम्प्लेक्स है, एक्चुअली नॉट कॉम्प्लिकेटेड, बहुत कॉम्प्लेक्स है। तो जैसे घर में एक इलेक्ट्रिसिटी का बोर्ड होता है, एक वायर होता है, वी ऑल नो कि जब इलेक्ट्रिसिटी वायर के अंदर से फ्लो करता है तो उसका एक कुछ कैरेक्टरिस्टिक्स होता है, उसको प्रोटेक्ट करने के लिए वी यूज अ रेजिस्टर, राइट? उसको एनहांस करने के लिए और स्टोर करने के लिए वी यूज कैपेसिटर, पंखे में कैपेसिटर लगा होता है। तो इसी तरह से अलग अलग प्रॉपर्टी और अलग अलग नेचर ऑफ रॉक जो है वो अलग अलग प्रॉपर्टी ऑफ इलेक्ट्रिसिटी फील्ड को रिस्पॉन्स करता है। ओके, जैसे सलाइन वाटर इज मोर कंडक्टिव एंड फ्रेश वाटर इज नॉन कंडक्टिव, राइट। द सिंपल एग्जांपल कि उसके अंदर जो आयंस है सैलिनिटी की वजह से देयर इज इंक्रीज इन आयन। फ्रेश वाटर और प्योर वाटर के अंदर देयर इज नो आयन, देयर इज ओनली H2O। ओके, सो दे विल नॉट कैरी करंट विद देम। सो इस तरह से आवर मदर अर्थ इज सो हेट्रोजेनस कि वहां पे देयर इज लॉट ऑफ इलेक्ट्रिकल फेनोमेनन्स गोइंग इन। सो दिस लॉट ऑफ इलेक्ट्रिकल फेनोमेनन्स आर ऑफ डिफरेंट टाइप्स। हम लोग इसके बारे में और भी ज्यादा डिटेल में बात करेंगे। एक होता है रेजिस्टेंस टू द फ्लो ऑफ ये इलेक्ट्रिसिटी, वन इज द कैपेसिटेंस, वन इज अ डाइलेक्ट्रिक कांस्टेंट टू इट। ये सारा अलग अलग नेचर के वजह से देयर इज लॉट ऑफ इलेक्ट्रिकल मेथड्स व्हिच केम इनटू द पिक्चर। So resistive और there if the nature of the rock is resistive और conductive, उसके बेसिस पे इलेक्ट्रिकल प्रॉपर्टी के ऊपर में और इलेक्ट्रिकल मेथड के ऊपर में एक रेजिस्टिविटी का कॉन्सेप्ट आ गया और रेजिस्टिविटी सर्वे का कॉन्सेप्ट आ गया, राइट। उसी तरह से आईपी इंड्यूस्ड पोलराइजेशन, सो नेचर ऑफ आयंस के ऊपर में हाउ द आयंस विल कैरी चार्ज और दे विल स्टोर इट और दे विल hold it for a time and then they will the charge will slowly precipitate or decay। उसके बेसिस पे आईपी आ गया। इसका प्रिंसिपल और कॉन्सेप्ट के बारे में हम और ज्यादा डिटेल में we will talk about it। So in the same way there is SP also which I have not talked in this slide। Okay, there is a factor is there, IP का है। Okay, there is SP। तो बहुत सारा अलग अलग मेथड्स है, कॉन्सेप्ट्स है। Okay, so here in this slide I am just talking on the generic principles of electrical method। One is the resistivity, one is the different properties, one is the flow of ions when they are induced to electric currents। So resistivity में nothing but directly हम लोग करंट पंप करते हैं सरफेस के अंदर, वो करंट जाता है अर्थ के साथ और जो भी प्रॉपर्टी वहां पे है टॉप प्रॉपर्टी लेयर्स के हिसाब से चेंज होते हुए अलग अलग वे में दे इंटरेक्ट विथ द अर्थ मीडियम और उसके वजह से इट गिव राइज टू ए डिफरेंस इन पोटेंशियल डिफरेंस, है ना। तो रेजिस्टिविटी के अंदर में वेरी जेनरिक वी इंजेक्ट करंट इन ग्राउंड, measure the potential difference which is arising, then उस potential difference से we try to understand the apparent resistivity distribution in the subsurface, and this apparent resistivity distribution will change or it is dependent on the electrode or the electrode geometry we are choosing to acquire the data। Okay, so there are different इस मेथड में बहुत सारा डिफरेंट ये इलेक्ट्रोड मेथड है जो हम यूज करते हैं। कॉमन है एक यहाँ पे नाम दिया है, दैट इज वेनर, श्लम्बर्जर, डाइपोल डाइपोल, पोल पोल। each of these different the methods, common array methods are different with respect to resolution and depth sensitivity। keep this in mind, हम लोग इसके बारे में और सारा डिटेल में बात करेंगे in this respective chapter। then the second one is IP। आईपी में क्या मेजर करते हैं हम लोग? चार्जेबिलिटी। ये दिस इज यूजफुल फॉर डिसेमिनेटेड सल्फाइड। ओके, आई हैव गिवन दिस हियर। डिसेमिनेटेड, ये नोट दिस, एक डिसेमिनेटेड सल्फाइड डिपॉजिट है। गो बैक टू योर इकोनॉमिक जियोलॉजी क्लास, व्हाट इज अ डिसेमिनेटेड सल्फाइड डिपॉजिट है। उस तरह के डिपॉजिट को आईपी इज मोर यूजफुल टू डिटेक्ट देम, और आईपी इज द बेस्ट मेथड इन जियोफिजिक्स टू explore a disseminated sulfide deposit। Give me a quick name of disseminated sulfide deposit। Give me quick names of few। No one is with me, या फिर इकोनॉमिक जियोलॉजी का रिवीजन नहीं हुआ अभी तक? Okay, let's move forward। The factors affecting in resistivity, जैसे ग्रेविटी में हम लोग ने देखा हाइट के वजह से, टेरेन के वजह से, और मैग्नेटिक में हमने क्या देखा? रेमिनेंस मैग्नेटिज्म की वजह से, रीजनल मैग्नेटिक फील्ड की वजह से, पोजिशनिंग ऑफ बॉडी की वजह से, है ना, डायरेक्शन ऑफ मैग्नेटिक फील्ड। इन सारी चीजों की वजह से वो मेथड्स इफेक्ट होते हैं। ऐसे ही in electrical method, the factor which affect the resistivity are the porosity of the rock, the fluid conductivity, the clay content, the temperature of the fluid, the temperature of the rock formation. ये सारा चीज उसको इफेक्ट करता है. Practical question, quick practical question. I will not say the question. Anyone wants to talk about this practice question? Anyone?
No, sir.
No, sir. I was expecting yes, sir. In resistivity survey, why does clay rich layer often show low resistivity? Go back to your class, go find out rocks which are clay rich. Give me an example of rock which is clay rich.
Shale, sir.
Shale,
Thank you,
mudstone.
shale, mudstone. Thank you. Clay rich, rock, shale, and mudstone. So they often show low resistivity. Okay. Why? Because clay hold bound water and high ionic conductivity. Is that simple, guys? Is it that simple? जो मैंने question और answer लिखा है.
I'm not sure, sir, but I think that due to high packing, sometimes the resistivity will also be high. Not
Thank
always
you.
water
Very,
is
very good.
present in the pores of clay.
Very good. Very good. Thank you. That's a very right answer. So because clay hold bound water and have high ionic conductivity. So that is the reason it will be showing low resistivity. Not always, because क्ले रिच जो रॉक है उसके अंदर बाउंड वाटर भले ज्यादा होगा, उसकी हाई आयनिक कंडक्टिविटी भले ज्यादा होगी, बट दैट डिपेंड्स ऑन दी फिजिकल कैरेक्टरिस्टिक ऑफ रॉक. एज वन ऑफ यू गाइज रिप्लाइड कि उसका कॉम्पैक्टनेस, हाँ, उसमें वाटर बाउंड वाटर कितना है. ऐसे ही अगर वो एक सैंडस्टोन के पास में है तो व्हाट विल बी द रेजिस्टिविटी वेरिएशन. सो दीस आर द क्वेश्चन. दैट्स व्हाई आई सेड दिस इज अ फूड फॉर योर थॉट कि ये सारा क्वेश्चंस है जिसके बेसिस पे यू शुड थिंक मोर. Okay, I hope this is helpful for you. If you give me a right feedback, I will try to include more of these in the upcoming classes, or I will skip to this practice question. Let us move to the interpretation and use of electrical method. So there is different kind of methods. There is 1D profiling, 2D, that there is 3D as well. Schlumberger is a good example of Schlumberger method is a good example of 1D sounding. Then there is Venner. It is a 1D profiling for layered sequence. There is also 2D, 3D imaging with inversion. That is nothing but ERT, electrical resistivity tomography. Keep this concept in mind. Somewhere you should write it down. That is ERT, capital E, capital R, capital T. Electrical resistivity tomography. Go back to your school notes or Google it. What is tomography? And we will be, जब ये चैप्टर के बारे में बात करेंगे, I'll talk more about it. Applications, rest electrical, mostly 90% of the time it is used for groundwater exploration, groundwater mapping, aquifer characterization, contamination mapping, identifying in economic geology, sorry, in environmental geology, and in engineering geology, characterization of surface, saturated and unsaturated lithologies or strata, जहां पे हम लोग फाउंडेशन बिल्ड कर सकते हैं अपना. Limitations. जब हमने बोला कि हमारा मदर अर्थ इज so heterogeneous, one of the very critical limitation of electrical surveys are the cultural noise, है ना, and the contact of electrode is an issue sometime. When I say cultural noise, मतलब बहुत सारा चीज है नीचे में जो बड़ी है. There is pipeline fences which are very sensitive to the electrical field. There is lot of change, or in near surface there is lot of heterogeneity. Let's say ऊपर का few meters is laterite, नीचे गए you are seeing a saturated zone of sandstone of few meters. Then there is few meter compact zone which is affecting the flow of current. So it's very heterogeneous, and that's why these surveys are very sensitive. Resolution decreases with depth, so it's a depth sensitive method. जैसे जैसे डीपर डेप्थ में जाते हैं वैसे वैसे वी लूज द सिग्नेचर ऑफ इलेक्ट्रिकल करंट्स, वैसे वैसे सैचुरेट होता जाता है, वैसे वैसे इलेक्ट्रिकल जो करंट्स पास हो रहे हैं सब सरफेस में दे डाई आउट और दे फेड आउट. Practical question: when would you prefer dipole over Banner array? We will talk about this in more detail. Read it out. I'll share the slides. Read it out. Electromagnetic methods. जैसे हमने electrical पढ़ा, there is also a phenomenon which is given rise to electromagnetic concept in geophysics. Okay. So here two things are happening simultaneously. One is electricity is coming into the picture. One is the magnetic field or the magnetic characteristic of Earth is coming into the picture. So there is a very famous scientist called Maxwell, Planck Maxwell. So he introduced this concept. वहां पे उसने क्या देखा कि जैसे ही इलेक्ट्रिक फील्ड कहीं भी किसी भी मीडियम से प्रोपोगेट होता है तो इट गिव्स राइज टू magnetic field as well. So the like if I say in a very layman language, a changing electrical field gives rise to a changing magnetic field, or a changing magnetic field give rise to a changing electrical field. So एक अगर वायर है जिसके अंदर से करंट फ्लो हो रहा है, Are you with me guys? एक वायर है जिसमें से करंट फ्लो हो रहा है, तो वो वायर के सराउंडिंग में और चारों तरफ जो है सर्कुलर मैग्नेटिक फील्ड क्रिएट हो जाता है. दिस इज ऑल्सो ए कॉन्सेप्ट विच इज हाईली यूज्ड इन मेडिकल साइंस, जैसे MRI, जैसे CT स्कैन. दिस इज हाईली बेस्ड ऑन दिस कॉन्सेप्ट ऑफ इलेक्ट्रोमैग्नेटिज्म. So why electromagnetism came into the picture? So this method is dependent on the induced. Remember when I say induced EM field, this is nothing but ये जो प्रॉपर्टी है इलेक्ट्रोमैग्नेटिज्म का, इट्स नॉट देयर विद इन अर्थ, है ना, कि अर्थ के अंदर में कोई रॉक नहीं है जिसके अंदर EM फील्ड है. दिस इज अ नॉट ए पैसिव फील्ड और ए पोटेंशियल फील्ड मैटर, इट इज ए एक्टिव फील्ड. मतलब हम क्या कर रहे हैं, हम अर्थ के अंदर में एक वायर के ऊपर में करंट फ्लो कर रहा है, उस फ्लो ऑफ करंट की वजह से एक मैग्नेटिक फील्ड जनरेट हो रहा है, उस मैग्नेटिक फील्ड की वजह से एक चेंजिंग इलेक्ट्रिकल फील्ड जनरेट हो रहा है. द वेरी बेसिक कॉन्सेप्ट, वेरी एकदम लेमन लैंग्वेज में बोला है, वी विल गो इनटू मोर डिटेल्स. सो इलेक्ट्रोमैग्नेटिक मेथड में वी इंड्यूस्ड इलेक्ट्रोमैग्नेटिक फील्ड, वी मेजर द रिस्पॉन्स और the response which is controlling the subsurface flow of this electromagnetic field. So nothing but any material which is causing this change in electromagnetic field, in variation of changing electromagnetic field, will be conductive towards electromagnetic field and or resistive towards electromagnetic field. Remember, when I say resistive or conductive here, it is not same to resistivity. ठीक है. EM और इलेक्ट्रोमैग्नेटिक फील्ड में दो तरह से सर्वे होता है. एक टाइम डोमेन में होता है जिसको हम लोग TDEM बोलते हैं, टाइम डोमेन इलेक्ट्रोमैग्नेटिक फील्ड, और एक फ्रीक्वेंसी डोमेन में होता है, एक उसको हम लोग क्या बोलते हैं, FDEM. तो टाइम डोमेन में क्या होता है, हम टाइम के हिसाब से इलेक्ट्रोमैग्नेटिक फील्ड को वेरी कराते हैं एक कांस्टेंट फ्रीक्वेंसी पे. ठीक है, एक कांस्टेंट, लेट्स से कि 10 हर्ट्ज का फ्रीक्वेंसी मैं यूज कर रहा हूं और उसको एक पर्टिकुलर टाइम के लिए इंजेक्ट कर रहा हूं अर्थ में, एंड देन फॉर अ टाइम आई एम स्टॉपिंग द फ्लो ऑफ करंट, आई एम मेजरिंग द रिस्पॉन्स टू इट. बट फ्रीक्वेंसी डोमेन में क्या होता है, वी यूज करंट ऑफ डिफरेंट फ्रीक्वेंसीज, 5 hertz, 10 hertz, 15 hertz, 25 hertz, and when we see कि 5 hertz की वजह से कितना चेंज हुआ और द कॉन्ट्रास्ट आया इलेक्ट्रोमैग्नेटिक बॉडीज का, और सॉरी फील्ड का, 10 में कितना हुआ, 15 में कितना हुआ, 25 में कितना हुआ. तो बेसिक एज अ जियोलॉजिस्ट व्हाट यू जस्ट नीड टू अंडरस्टैंड इज, एक टाइम डोमेन है और टाइम डिपेंडेंट है, और एक फ्रीक्वेंसी डोमेन है जो फ्रीक्वेंसी डिपेंडेंट है. ठीक है, विल कम टू इट इन मोर डिटेल. तो जैसे जब हम लोग ग्रेविटी और इलेक्ट्रिकल फील्ड जब हम लोग पढ़ रहे थे, जब ग्रेविटी और मैग्नेटिक देख रहे थे, ग्रेविटी इज डिपेंडेंट और कैन बी डन एयरबॉर्न, इट इज मरीन बेस्ड, इट इज ग्राउंड बेस्ड. सेम मैग्नेटिक, एयरबॉर्न है, ग्राउंड बेस्ड है, मरीन है। बट इलेक्ट्रिकल जो प्रॉपर्टीज है और इलेक्ट्रिकल फील्ड है, डायरेक्ट इलेक्ट्रिकल, जो प्रीवियस चैप्टर में था, ये इलेक्ट्रिकल रेजिस्टिविटी एंड आईपी, दीज आर डायरेक्ट फील्ड, ये सिर्फ ग्राउंड बेस्ड ही होते हैं। ओके, एयरबॉर्न नहीं हो सकता रेजिस्टिविटी और आईपी सर्वे, मरीन नहीं हो सकता, अभी तक नहीं हो रहा है डेंसिटी, सॉरी डायरेक्ट इलेक्ट्रिकल रेजिस्टिविटी और आईपी। इलेक्ट्रोमैग्नेटिक इन अदर way is airborne as well as ground based. Airborne EM will help you to rapidly evaluate the regional conductivity of the area, so mapping of the conductive rocks. There is one more thing which comes into play, which is magnetotellurics. इसके बारे में we will talk in very little detail, इतना कुछ इस पे क्वेश्चन भी आता नहीं है और ये थोड़ा सा complicated है। मतलब magnetotellurics अगर समझना है, you would have to understand little bit more of physics and math. But इसका concepts और application we will touch on. जहां पे इलेक्ट्रोमैग्नेटिक में हम लोग करंट इंड्यूस कर रहे थे और इंजेक्ट कर रहे थे और देख रहे थे, इलेक्ट्रोमैग्नेटिक में ऐसा नहीं होता, सॉरी मैग्नेटोटेलुरिक्स में ऐसा नहीं होता। मैग्नेटोटेलुरिक्स में क्या, जो अर्थ का नेचुरल इलेक्ट्रिकल फील्ड है, जैसे लाइटनिंग, ओके, लाइटनिंग को यूज करके वी ट्राई टू अंडरस्टैंड कि वो लाइटनिंग की वजह से भी कुछ इलेक्ट्रिसिटी प्रोड्यूस हुआ, राइट। फिर हाउ दैट इलेक्ट्रिकल फील्ड हैज इंटरेक्टेड विद द सबसरफेस, उसको स्टडी करके वी कैन also understand deep earth structures, very very deep earth structures. Practice question. Again, I will leave this to you. Can anyone talk on this? Anyone wants to talk or anyone has a question on this? What advantage does airborne EM provide for mineral exploration? Keep this with you. Keep this with you. Go back, think. EM methods, application and limitations. जैसे हमने बाकी सारे सर्विस का एप्लीकेशन और इंटरप्रिटेशन देखा, इसी तरह EM का एप्लीकेशंस. So EM is very very effective in exploration of minerals. ठीक है? It is very limited. It has very limited use in petroleum, but it is very helpful in mineral exploration. So कुछ भी तुम लोग को जैसे क्वेश्चन आएगा on exploration point of view, let's say sulfides, let's say graphite, saline water, इस तब पे, तो you have to recall this EM method in geophysics, है ना? Processing, जिस तरह से sensitivity थी ग्रेविटी और मैग्नेटिक फील्ड के डेटा प्रोसेसिंग में, उसी तरह से इसमें भी होता है. देन व्हाट वी डू, डेटा को लेकर के वी ट्राई टू इन्वर्ट, डीके कर्व्स वगैरह आता है, फ्रीक्वेंसी देखते हैं, रिस्पांस क्या था, conductivity versus depth, ये भी we will see in more detail. Estimate, we try to estimate two things, कि what is the conductivity of the medium as well as from what depth that conductivity difference is coming. Limitations, as in electrical field, these are very very limited or effective towards the nature of the response of rock towards electrical properties. So this is also very sensitive to near the surface conductors, है ना? This is also very sensitive to the geometry of the body. Okay, we'll go into more detail when we'll be talking on EM field. Anyone wants to talk on practical question? Guys, you are with me or you are bored? You want a small break? It's 7. Oh, already we are about to close the lecture. I am bending. Okay, let me rush. Guys, you are with me?
Yes, sir.
So would you mind if
Yes.
I extend a little bit, maybe 10 minutes?
Sure, sir.
Okay, don't get bored यार, मेरा पहला lecture है. You are with me?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
प्रैक्टिस क्वेश्चंस जो है ये मैंने सिर्फ और सिर्फ आपके लिए रखा है. इसको आप लोग पढ़ो, इसके बारे में समझो और इसके अराउंड ही कॉन्सेप्ट्स को डेवलप करो, which will help you to target those questions जो भी आएगा in and around this topic. MT we will skip for now, deep imaging के लिए रहता है. MT maybe we will talk in more detail when we will be touching on the MT chapter. Seismics. So जैसे ग्रेविटी और मैग्नेटिक और इलेक्ट्रिकल था, वैसे ही फोर्थ थिंग इज द seismic मेथड. अभी seismic में there are two different things which happens at the same time. मतलब जब एक seismic wave subsurface में travel करता है तो there are two phenomena which is happening. जैसे इलेक्ट्रिकल में था ना, रेजिस्टिविटी होगा या फिर आईपी होगा, that is because of different nature of rock which is causing different behavior towards flow of electricity. इसी तरह से when a seismic wave is propagating through from the surface, it either gets refracted or gets reflected. There are two concepts. One is refraction, one is reflection. हम लोग इसके बारे में और डिटेल में बात करेंगे, but for this slide, seismic refraction is nothing but uses the first arrival or the travel time to map the layer velocity and depth of the surface. So the key difference is, जैसे एक वेव ट्रेवल किया, लेट्स से कि दिस इज अ सरफेस, यहाँ पे एक साइस्मिक वेव जनरेट हुआ, ये ट्रेवल किया, लेट्स से दिस इज द सेकंड सरफेस, यहाँ पे हिट हुआ एंड इट ट्रेवल्स बैक. Okay, so we only see the first arrivals, the rays which are reaching first at the receiving end. यहाँ पे let's say कि बहुत सारा receivers है, जिसको हम लोग seismophones बोलते हैं या फिर geophones बोलते हैं. ठीक है, only the first arrivals are studied in refraction. So that is the basic distinguishing feature. This method is good for depth to bedrock studies or velocity profiling, shallow mapping. The data can be acquired using sources like sledgehammer. Sledgehammer मतलब बड़ा सा हथौड़ा we rock or we just blow it on the surface of earth, जिसके वजह से seismic waves generate होता है. Or we can use explosive, जो oil and gas में use होता है. We can use heavy weights to drop on the surface of earth. Due to heavy weights, the energy of seismic wave will be high, which will travel down to a greater depth, and then we will be seeing the first arrivals. So very easy. जो receiver है उसको हम लोग क्या बोलते हैं, geophone और seismograms or seismographs. We will come into these topics more detail. Then what we process only the first arrival or the first phase. What is the character which is causing this first arrival or the distinction is the speed and the travel time of that wave. Limitations, जैसे बाकी सारे properties का limitation है, वैसे भी इसका limitation है. What is that limitation? Is the complex geology and the low velocity zones. Low velocity zones मतलब वो zones में velocity of seismic waves is so less that it will not get refracted back to the geophones, and we will not be able to understand where the surface is. जैसे reflection देखा, अभी the second concept is reflection. Okay, reflection is nothing but, जैसे first time we are striking here or let's say at M we are producing the seismic wave. यहाँ पे ये travel हुआ, ये second एक layer था अर्थ में, यहाँ से first जो ray इसको refract होकर के वापस आया, उसको हम लोग स्टडी कर रहे हैं seismic refraction में. ठीक है, और रिफ्लेक्शन में क्या कर रहे हैं, ये प्रोपोगेट होगा, तीन चीज होगी यहाँ पे इस बाउंड्री पे. वन इज, एक तो रिफ्रैक्ट होगा, एक रिफ्लेक्ट होगा और एक ट्रांसमिट होगा वेव which is traveling along this boundary. So the wave which will go down and deeper on earth will help me to understand the deeper complexity of earth, right? So that method is more to do with the deeper depth exploration in seismic methods, which is most of the time used in petroleum exploration, oil and gas industries. ठीक है, so food for thought is shallow surface seismic में क्या होता है, seismic refraction, और deep surface seismics में क्या होता है, seismic reflection. Okay guys, you are with me? इसमें बहुत सारे receivers का array use करते हैं. CMP is a common method which is used in staking off all the travel time or the rays which will travel back to Earth's surface. Then this is a high resolution and deep penetration method. Okay. interpretation, what we interpret, we try to understand the velocity and the density contrast of the medium, which is nothing but velocity into density. Write this formula somewhere. एक आ सकता है IP sorry impedance. Impedance किसी भी अगर medium का दिया हुआ है, the question can be like calculate the impedance contrast between the given layers. और ऐसा layers बना दिया होगा पेपर में, layer 1, layer 2, layer 3, और एग्जांपल दे दिया होगा sandstone, shale, sandstone, और उसका प्रॉपर्टी दिया होगा what is velocity and the density. So layer 1 का velocity, layer 2 का velocity, layer 1 का density, layer 2 का density, and the question may ask you to calculate the acoustic impedance or the impedance contrast, which is nothing but velocity into density of the same layer. Okay. Going forward, limitations. Limitations is it is very expensive and challenging for acquisition. So that it is the most expensive method in geophysical exploration. ठीक है? It requires a good source and a receiver deployment. Okay. Let's say you are using an explosive. अच्छा विस्फोट होगा, the energy will be strong enough to propagate, but at the same time you are using sledgehammer, the strength of the seismic wave will be low and it will not penetrate deep into the earth's surface. Then it is processing intrinsic. There is lot of steps which is involved in processing of seismic data. Question: why is seismic reflection preferred in petroleum exploration? Answer is it is. Guys, you are with me? It
Yes,
gives
sir.
a detailed image of the seismic horizons, the structural traps, and the reservoir scale. Right? Next, जब हम लोग ने we talked about gravity, magnetic, electrical, electromagnetic. We saw electrical, we saw mag, we saw grav, we saw seismic, reflection both. Now it's time to understand a one more chapter which will be there, which is on the well logging or the borehole logging. So ये nothing that जो physical concept हम लोग ने अभी तक पढ़ा, वो सारा physical concept का introduction हम लोग ने well logging में कर दिया, right? तो एक borehole होगा जिसके अंदर we will put a tool which is called a downhole tool. इसका एक टेक्निकल नेम है जिसको हम सॉन्डे बोलते हैं, SONDE, सॉन्डे, SONDE, सॉन्डे, इन फिजिकल सॉरी इन ऑयल एंड गैस एक्सप्लोरेशन. ठीक है, उस टूल का नाम है. That provides a in situ characterization of all the, it can give the information of density, it can give information of magnetic susceptibility, electrical property, resistivity, and conductivity. It can give you other or the response of other physical properties, as in the electromagnetic of the, also the radioactivity of the medium. Either it is induced or either it is the spectral radioactivity. ठीक है, सोनिक पोरोसिटी, हम लोग इसके बारे में बहुत सारा डिटेल में पढ़ेंगे, बट एज ऑफ नाउ दिस इज जस्ट इंट्रोडक्शन. पर्पस क्यों हम लोग बोरहोल लॉगिंग करते हैं और वेल लॉगिंग करते हैं? पर्पस इज जब हम लोग ने एक होल ड्रिल कर लिया किसी भी फॉर्मेशन में, उसके अंदर जो लिथोलॉजिकल वेरिएशंस है उसको आइडेंटिफाई करने के लिए, तो दिस कैन एक्ट एज अ डायरेक्ट टूल टू कैरेक्टराइज द सबसरफेस होराइजन और टू मैप और टू understand the distribution of physical property within the subsurface within that local area जहां पे वो बोरहोल है. एक कॉन्सेप्ट है जिसको बोलते हैं LWD. ये बहुत वाइडली बहुत फेमस भी हो गया है इन क्वेश्चंस. दिस इज नथिंग बट लॉगिंग वाइल ड्रिलिंग. तो वाइल्ड लाइन लॉगिंग इज डिफरेंट देन लॉगिंग वाइल ड्रिलिंग. मतलब वाइल्ड लाइन लॉगिंग इज नथिंग बट एक बोरहोल हो गया है, उसके बाद में होल खत्म होने के बाद में वी आर डूइंग द लॉगिंग. द सेकंड इज लॉगिंग वाइल ड्रिलिंग, मींस द ड्रिलिंग एक्टिविटी इज गोइंग ऑन, एट द सेम टाइम यू आर आल्सो डूइंग द पेट्रोफिजिकल लॉगिंग और द बोरहोल लॉगिंग. दैट इज कॉल्ड लॉगिंग वाइल ड्रिलिंग. इस केस में लॉगिंग इज साइमल्टेनियस विद ड्रिलिंग, इस केस में लॉगिंग इज पोस्ट ड्रिलिंग एक्टिविटी. मतलब ड्रिलिंग खत्म हो गया, देन यू आर डूइंग द डेटा एक्विजिशन. कुछ नहीं है, ओनली द थिंग इज द डिफरेंस इन टाइम. एक रिलेटिव टाइम में है और एक रियल टाइम में है. This is highly used for calibration of the surface geology. जैसे density contrast आया था, तो density logging करके we try to understand the density variation in surface. वैसे ही downhole density logging करके we try to understand which layer of the rock was responsible for what density characterization. Question: what rock signature would indicate a clear sandstone reservoir? Okay, read about this in more detail. Just don't jump to this generic answer. Moving ahead, radiometric method. This is the most simplest thing you will. मतलब ये हमारा चैप्टर में कितना सिंपल मेथड होगा, you guys will enjoy. एकदम सिंपल है, कुछ भी चैलेंज नहीं है इसके अंदर, is very direct and straightforward. It depends on the radioactivity of the rocks. अभी radioactivity एक ऐसा phenomenon है जो is very limited to the surface. जैसे ही we will go away from that medium which is causing the radioactivity, it will die off, it will fade away. So it nothing but measures the natural gamma radiation which is coming from the potassium, uranium, thorium, all these minerals, and this is often airborne. Why airborne, guys? ताकि फटाक से एक बड़ा एरिया का फटाक से मैपिंग करके और रेडियो एक्टिव सिग्नेचर्स को पकड़ करके मैप करके we can try to understand what is the rock which is causing this variation in radiometric signals. ठीक है, the application is straightforward. It is to understand the rock formation which is soil or regolith cover, or the lithology discrimination. कहाँ पे एक igneous formation है, कहाँ पे एक sedimentary formation है. Processing is not that challenging. It's simple. पोटेशियम का कितना रिस्पांस, थोरियम, यूरेनियम का कितना रिस्पांस आ रहा है, कौन सी विंडो में ये रेडियो एक्टिविटी है, because it is dependent on the mineral, so it will be in different scales. Correction is also not that challenging. Only the difference is the altitude. जितना क्लोज सरफेस के रहेगा उतना अच्छा सिग्नल्स आएगा, जितना दूर सरफेस से रहेगा उतना पुअर सिग्नल्स आएगा, बिकॉज लेट्स से यहाँ इस सरफेस से रेडियो एक्टिविटी जनरेट हो रहा है, तो इट विल फेड अवे एज यू मूव इवन कपल ऑफ फीट्स अवे फ्रॉम द सरफेस. I will leave this question to you, read it out in later. Next is the GPR, ground penetrating radar. This is a concept very much used in the infrastructure or the near surface geophysics. In engineering geology, जहाँ पे tunnels, roads, highways, bridges, बड़ा dams, बड़ा structures बन रहा है, वहाँ पे we try to understand the एकदम क्लोज टू सरफेस में क्या क्या चेंजेस है, कंट्रास्ट है फिजिकल प्रॉपर्टी का. ऑल्सो दिस इज हाईली यूज्ड फॉर डिटेक्शन ऑफ बरीड पाइपलाइंस, डिटेक्शन ऑफ बरीड केबल्स, डिटेक्शन ऑफ बिग हेलोज. लाइक एक बहुत अच्छा रोड है जिसके नीचे कोई तो एक बड़ा पाइपलाइन गया था, मे बी 50 years प्रीवियस, आज से 50 साल पहले, बट किसी को पता नहीं है वो कहाँ पे है. तो यू कैन यूज दिस मेथड टू मैप दैट हेलो or that drainage pattern or that drain. इसके बारे में we will not talk in that detail. इतना ज़्यादा questions आते नहीं है GPR पे. The only thing you need to understand is it's very sensitive to depth. So it is very sensitive to depth, as well as it is also very sensitive to the resolution. You can resolve a body which is even a centimeter thick to a several meter thick. Also, it depends on the depth and the frequency and the ground conductivity. Here when I say conductivity, it is not same as the electrical conductivity, it is not same as the electromagnetic conductivity. Here is a different concept which will come in picture, which is dielectric constant or the dielectric property of a medium. Maybe write it down somewhere. GPR is dependent on the which physical property? It is dependent on the dielectric contrast of the subsurface. It is used for near surface engineering, archaeology, utility detection, shallow hydrological studies. Limitations is conductive soils like clay, they attenuate the signal because it is dependent on the dielectric property. So a clay or a very rich conductive soil will not allow to penetrate the signal in deeper depth, and it will restrict the flow of signals in depth. It's a trade-off between depth and frequency. When I say a trade-off means greater the depth, lower the frequency. Higher the frequency, shallower the depth. Means it is vice versa. High frequency use करके shallow depth में we can explore. Low frequency use करके we can explore for deeper depth. But as the depth will increase, it will attenuate, right? It will attenuate and we will not see the signatures. In which ground would GPR perform poor? This is also a good question. किस तरह का ground में GPR will not be useful? The direct answer to it is clay-rich saline soils. Clay-rich soils or saline soils, like guys, I'll leave this to you. Integration, we'll talk about it. Integration of geophysical surveys and rations. So it is not that straightforward. Geophysics can simply not play a single role. So एक सिंगल जियोफिजिकल सर्वे जो है वो काम में नहीं आएगा. बहुत बार एप्लीकेशन फ्रंट पे जब we will have to integrate a lot of different geophysical method. Let's say airborne electromagnetic, then we go for ground-based electrical or IP survey, then we go for either resistivity, then we can take a call for drilling. Right? That's the last stage in exploration. No single method reveals all. ठीक है? So integration of all the different ways, geology, geophysics, will help you to solve the non-uniqueness problem in the subsurface. Multi-physical inversion. I will not go into inversion and joint inversion. Okay. Name 2 reasons for integrating multiple geophysical data set. It will reduce ambiguity. It will confirm the depth, target and geometry and physical property of the rocks. So integration, दो different method को, 3 different method को integrate करने से we will introduce good confidence in the survey. Okay, guys. Application in mineral exploration. This is a very generic overview. हम लोग इसके बारे में बहुत सारा डिटेल में बात करेंगे. Mineral exploration में सबसे ज्यादा EM, magnetics, electrical surveys, regional magnetic and gravity, ये सब यूज होता है. Okay, seismic बहुत कम यूज होता है because seismic is very costly. Seismic is dependent on the impedance of rock, जो igneous और metamorphic rock में नहीं रहता. Hard rock में इतना काम नहीं करता seismic. Soft rock में ज्यादा काम करता है seismic. So most of the time when we are going for mineral exploration, we will talk about in more detail when I will refer to few specific examples, few sulfide mineralization which was explored using geophysical methods. Okay, so prospecting से लेकर के regional mapping तक और local scale target identification तक, targeting तक, we can use different combination of geophysical method for mineral exploration. Okay. How would you prioritize method for covered greenfield areas with suspected sulfide mineralization? Now you have to understand sulfide. When I say sulfide mineralization, you have to understand, go back to your economic geology class, understand how sulfide deposits are formed, what is the characteristic of metallic minerals, sulfide deposits, what kind of sulfide it is, how it is forming. Okay, then you try to understand the physical nature and then you try to bring in geophysics. The second vertical is the hydrogeology and groundwater. When we say hydrogeology and groundwater, it is most of the time the electrical survey, the resistivity and IP survey. Sometimes very little bit EM. Okay. And the second is GPR for very shallow water table detection, mapping of resistive soils, all these. Right. तो जब हाइड्रोजियोलॉजी का, जब मिनरल एक्सप्लोरेशन का बात करेंगे, रिमेंबर रीजनल ग्रेविटी, रीजनल मैग्नेटिक्स, ग्राउंड बेस्ड मैग्नेटिक, समटाइम्स फॉर BIF and magnetic minerals, and then it is EM, airborne EM, and IP. And guys, you are with me? I think everyone lost me here.
No, so
Am I too
we're
late? Okay. Mineral exploration, then groundwater may, it is most of the time resistivity and IP. Okay, IP is sometimes, EM sometimes, but most of the time electrical survey, electrical resistivity. Question. What geophysical signature would indicate a saline water? Low resistivity and high conductivity, because saline water has good amount of ions within it, which will help the flow of electrons, electrical currents. That's why it is conductive in nature. It is low resistive. ठीक है? Application in engineering geology. So GPR, seismic, shallow seismic methods. जहाँ पे हम लोगों ने refraction का नाम लिया था, refraction, seismic refraction method, and GPR. These are the key geophysical methods which are used in engineering geology. Applications for detection of voids, karst topography detection, जहाँ पे karst की वजह से there are different halos in those limestone beds. So identifying zones of weakness, bedrock depth, shallow groundwater, and foundation designing. Okay. But see, I have also introduced one more concept here, which is okay, sorry. Okay. MASW. MASW. Write it down somewhere. Go search the full form of MASW. Okay, guys. Also in practice question, there is MASW coming in. Okay. Oil and gas. So mineral में क्या था guys? Airborne magnetics or regional magnetics, gravity. ठीक है? Followed by electrical, mostly electromagnetic method and IP. उसके बाद क्या आया? हाइड्रो मतलब ग्राउंड वाटर. हाइड्रोजोलॉजी में रेजिस्टिविटी है ना. उसके बाद इंजीनियरिंग में क्या आया? seismic refraction. Okay, and GPR. Oil and gas में, see, very peculiarly, oil and gas में this is seismic reflection. So in oil and gas, I am not talking about the regional oil and gas exploration, which is done using regional gravity and magnetic. जहाँ पे we try to identify the basins, the bigger basins where oil and gas deposits can form. वो we will trace with gravity low and mag low areas, right? उसके बाद में when we are in field, we use seismic reflection method. Okay, for oil and gas. We'll go in more detail when we'll talk about this applications of seismic in oil and gas, but it is very useful for characterization of reservoirs. The seismic attributes which will give rise to different acoustic impedance, which will give rise to different seismic horizons, which will be coming from different physical properties, the physical, petrophysical properties of the rock. I'll not touch the practice question. तो ये सारा जब हम लोग बात कर रहे थे, बहुत सारे इंस्ट्रूमेंट्स हैं और बहुत सारे प्रोसेसिंग मेथड्स हैं जियोफिजिक्स में जो यूज होते हैं. ठीक है. तो ग्रेविटी में क्या यूज होता है? ग्रेविमीटर. दो तरह का होता है, एक रिलेटिव एंड एक एब्सोल्यूट. ठीक है. Which in gravity survey the instrument has to be very precise and it has to be very sensitive towards the change in gravitational force. So accuracy and precision matters in gravity alone. ठीक है. Magnetic में क्या होता है? We call it, the instrument is called as magnetometer. There are different kind of magnetometer working on different principles. One is proton precision, one is optically pumped gravitymeter. ठीक है. Magnetometer. Magnetic में क्या? We need to do a diurnal correction. We'll talk about this diurnal correction. EM में क्या होता है? Resistivity में क्या होता है? We have a transmitter. Transmitter मतलब क्या? Transmitter is nothing but which is transmitting the energy, and the receiver is nothing but when this energy is transferred into the subsurface, interacts with the subsurface characters or inhomogeneity, comes back to the surface. We have a receiver to measure the response of the transmitted energy. So we have an electrode array in which few of the electrodes act as transmitter, few as receiver. The attenuation to the electrode contact is very, very effective in this survey. Then in seismic, we have different sources. Sources में क्या था? एक sledgehammer, it could be a weight drop, it could be explosive. The weight drops, remember the weight drop or the heavy weight drops are referred as vibro size. ठीक है? Write it down, vibro size. Google करना vibro size, you will get lot of images. बड़ा सा एक ट्रक होगा, ट्रक के बीच में नीचे में एक बड़ा सा मेटल प्लेट होगा. वो मेटल प्लेट को स्प्रिंग से अटैच करके we hammer it on the surface of the earth. उस इंस्ट्रूमेंट को वाइब्रोसाइज बोलते हैं. ये हो गया सोर्स. उसके बाद में वी हैव रिसीवर विच इज नथिंग बट जियोफोन और हाइड्रोफोन्स. ग्राउंड बेस्ड सर्वे है तो जियोफोन, एयर सॉरी वाटर बेस्ड है तो हाइड्रोफोन. वी विल कम एंड डिस्टिंग्विश बोथ ऑफ दिस कि क्यों अलग होता है, जियोफोन कैसे डिफरेंट होता है हाइड्रोफोन से. बट एक क्वेश्चन आ सकता है कि ग्राउंड पे जब साइस्मिक सर्वे कर रहे हैं तो उसका रिसीवर का क्या नाम होगा? दैट इज रिमेंबर जियोफोन. और वाटर में कर रहे हैं या फिर ओशियन या सी बेड पे कर रहे हैं तो इट इज हाइड्रोफोन वी आर यूजिंग. ओके, सो जैसे ईएम में ट्रांसमीटर रिसीवर का कॉन्सेप्ट था वैसे ही साइस्मिक में सोर्स और रिसीवर का कॉन्सेप्ट है. बोरहोल लॉगिंग, रिमेंबर आई टोल्ड यू sonde, SONDE, sonde is the name of the tool, and there can be multiple tools which is sensitive to gamma, sensitive to resistivity, conductivity, density tool, sonic tool, caliper tool. All of these will go into detail. The data quality in borehole logging matters a lot. It is dependent on the borehole condition. Okay. Once we have talked on the instrumentation and the acquisition part, we will see survey designing and planning. Basically कुछ नहीं है, बड़ा सा एक जेनरिक में समझो कि कोई भी जियोफिजिकल सर्वे करने से पहले क्या करते हैं हम लोग? सर्वे डिजाइन करते हैं कि कैसे हम डेटा एक्वायर करेंगे और उसकी प्लानिंग होती है. ठीक है. ऑब्जेक्टिव इज टू ड्राइव द डिजाइन सर्वे. ठीक है. एक अच्छा डिजाइन किया हुआ सर्वे रहेगा तो क्या होगा? रेजोल्यूशन वर्सेस डेप्थ ट्रेड ऑफ विल बी गुड. बजट कितना है मेरे पास? अगर कम बजट है तो मैं एक लो कॉस्ट जियोफिजिकल मेथड अडॉप्ट करूंगा. हाँ, इन्वायरमेंट कंस्ट्रेंट्स क्या क्या है, ये सारी चीजों पे डिपेंड करता है सर्वे डिजाइन एंड प्लानिंग. मैं किस तरह का ग्रिड पैटर्न सिलेक्ट करूंगा, स्पेसिंग क्या रहेगा मेरा लाइंस में, स्टेशंस में, लाइन ओरिएंटेशन क्या रहेगा, इलेक्ट्रोड स्पेसिंग क्या रहेगा, ट्रांसमीटर का स्ट्रेंथ कितना होना चाहिए, मतलब कितना एनर्जी मुझे यूज करना है, सोर्स कितना अच्छा होना चाहिए, है ना. इट शुड आई गो फॉर ए हाई सोर्स, शुड आई गो फॉर ए लो सोर्स. All are these are the variable when we are designing a survey and planning a geophysical survey. What is the purpose of the survey? Is it going to be an environmental objective? The objective is to understand the area. It should be of low cost. It should not destroy the environment. The precision should not be compromised, right? There should be not of noises in and around the area. What would be the my QAQC? मतलब किस तरह से मैं क्वालिटी ऑफ डेटा को इंश्योर करूंगा. ओके, उसके लिए क्या क्या बेसिक्स रहता है. दिस इज नथिंग बट द जनरल थिंग्स और द जनरल कॉन्सेप्ट्स व्हिच वी डील इन सर्वे डिजाइनिंग एंड प्लानिंग ऑफ ए जियोफिजिकल डेटा एक्विजिशन प्रोग्राम. डेटा एक्वायर होने के बाद क्या होता है दोस्त? प्रोसेस. वी गो फॉर डेटा प्रोसेसिंग. व्हेन वी एक्वायर द डेटा देयर इज नो लॉट ऑफ unwanted things also which is coming with the data, which is hampering my resolution, which is hampering my direct targeting, or which is not right to be looked directly when we are correlating with geology. So processing का goal क्या रहता है? मोटा मोटी goal is कि remove noise. Noise is nothing but any unwanted signal which is irrespective of the characteristic source, है ना. करेक्ट फॉर इंस्ट्रूमेंटेशन, गलत इंस्ट्रूमेंटेशन या फिर इंस्ट्रूमेंटेशन का हेमोजेनिटी की वजह से क्या रिस्पॉन्स आया. उसके बाद एनवायरमेंट इफेक्ट एंड एनहांस द सिग्नल क्वालिटी. सो दिस इज द बेसिक ऑब्जेक्टिव ऑफ और द गोल्स ऑफ प्रोसेसिंग द डेटा. In potential field processing, I talked about diradial correction in magnetic field, IGRF correction. There is terrain correction in both magnetic as well as gravity method. Then we use a lot of filters to enhance the signal strength. In seismic, we do deconvolution, we stack the data, velocity analysis, migration of all the depth and the source refractions. EM and resistivity में we filter the data, we do time gathering in EM, we do inversion of the acquired data. The importance of all these is nothing but good processing increases signal to noise ratio, S to N, signal to noise ratio, and quality of inversion result. Right? Data processing होने के बाद there is two things. Acquisition के बाद में processing, processing के बाद में inversion. There is forward and reverse inversion. We'll go back. Inversion. हम लोग जियोफिजिक्स में इन्वर्जन के ऊपर ज्यादा ध्यान नहीं देंगे because it is very 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 mathematical or it's not that easy for a geologist to understand. And I have not even seen a lot of direct questions coming on inversion methods. We will only talk about कि inversion क्या होता है और उसका किस तरह का concept और principles के ऊपर में हमको question मिल सकता है. Okay? So it could be a one-dimensional, two-dimensional, three-dimensional inversion. Forward inversion means you have the source response. We see कि इस तरह का source की वजह से कैसा data आएगा, उस तरह का data की वजह से किस तरह का signal आना चाहिए. That is forward modeling. Practical question: what is the major limitation of geophysical inversion? So non-uniqueness or multiple models can fit the data. इसका मतलब क्या है, guys, students? Non-uniqueness मतलब कोई भी इस तरह का डेटा नहीं है कि मतलब कि if this is the response or this is the data which is looking like this, मैं उसका inversion करूंगा तो I can never get back to a specific geology which is causing that signal or which is causing that data. Okay, so there could be multiple solutions to one model. So that is non-uniqueness and a non-uniqueness problem in geophysics. There can be multiple models which will fit to data. Means one geology can give rise to multiple data, multiple kind of scenarios. If I'll practice on a data acquired can give rise to a multiple geological scenarios. Then the last thing is the interpretation from the model which we have generated after inversion. So this is where you guys come in picture, right? Interpretation ke time pe. You try to understand the geology from the geophysics. When you try to understand geology, you also bring in geochemistry, you also bring in the borehole logs which you have acquired, lithological logs. So interpretation is a collective approach to understand the geophysical data from a geological point of view. Okay, you try to understand the uncertainty, the quality, the quantification of the data. Will not go into the details, but when we will be seeing this model or this chapter in geophysics, I will give you very very practical and relevant examples in and on which बहुत सारा questions आता है. Okay. The strategy, our strategy क्या रहेगा? Geophysics in competitive exams. So why we are here? We are here to practice for GATE, NET, GSI, all these competitive exams. I am not here to teach you geophysics and make you an MSc geophysics student, right? So my content will be very, very selective or elaborative towards the strategy of our course. Okay. We will also include example tips. ठीक है? The fundamentals, जो principles हैं geophysics में, जैसे there will be lot of equations coming into the picture in the upcoming courses, है ना? We'll see a lot of practical numerical problems, जिस तरह का what you can face in solving these questions, है ना? बहुत सारा questions हम देखेंगे, magnetic, gravity, seismic पे बहुत सारा देखेंगे, okay? Then practical approach देखेंगे, किस तरह से practical questions आएंगे, ठीक है? Previous years we will try to practice some question if time permits, but we will solve, definitely we will solve numerical problems. This is a question, किस तरह का question आ सकता है? Which physical equation underpins both EM and MT method? EM is electromagnetic, MT is magnetocaloric. So the equation, the physical equation is the Maxwell's equation. Guys, you're with me. We are at the end. So in the upcoming chapters or the classes, this is the roadmap which we will be following. Now we will break the coming sections into modules. In the first module, we will talk on the potential field. One chapter or the upcoming sections will be on gravitational method. When we will finish gravity, there will be potential field method, which is magnetic, then electrical, separate for EM, then slowly we will move towards seismic, logging, well logging, radiometric field touch on, processing inversion. We will not go into detail, but interpretation and integration will be lot when we will be dealing in the end of this course or curriculum. Weekly, we will touch on each and every topic, let's say 2 or 3 lectures per topic. And in the mid of the course, I will try to engage you with some mock test. Like, let's say I will throw a slide, there will be few questions which I will ask you to answer in real time. Okay, that will be not to judge your understanding on geophysics or not to understand kitna preparation ho gaya, but also to only to generate your understanding or generate your thought process around geophysics. Okay. Then in final, we'll try to have few sessions of the revision and the exam practice point of view. Okay. Summary will, let's not skip this slide. Summary, हमने आज क्या पढ़ा? हमने बस एक recap किया है कि basic broad geophysics में क्या क्या चीजें होती हैं, physical measurements क्या क्या होते हैं, geological interpretations कैसा होता है. We will talk. मतलब बहुत सारा हम लोग ने start किया geophysics को समझने से, why geophysics, what geophysics, then we concluded with the basics or the core applications. Okay. In the next class, we'll go deep into gravity and magnetic method. Okay. From physical principle, acquisition, processing, modeling, and some practice problems. Okay. Remember, bring calculator. Thanks, guys. I think that was and I have exceeded half an hour. Sorry for that. Okay, let me stop sharing. Okay, people who are online, could you please unmute yourself? Anyone can unmute yourself, wants to talk anything about the lecture? Stop sharing, stop presenting, stop sharing. Okay. Guys, can you hear me? Can you see me? Tarun
Yes,
is
sir.
there.
Yes, sir.
Thanks. Do you have any comments on the way we are going or any comments on what we talked on today?
No comments. It's a good thing to go like that.
You have any expectations from your side? I want to understand ki kaise you want to approach to this geophysics. Is the formation good? Let's go like that, module by module, method by method. After each method, I will give some practical questions, which will be both numerical as well as MCQ or MSQ type. That sounds good, Tarun?
Yes,
Yes,
sir.
sir.
This
Okay.
seems good.
And since I understand you guys are from geology background, I will not talk more on the derivation of the equation. I will not talk about the equation ki kis tarah se equation aa raha hai. I will not go into detail. I will only touch on the key formulas. Okay.
Okay,
Yes,
sir.
sir.
But most of the time I will be referring to lot of the practical application. Jaise aaj we saw that practice questions. I will throw a lot of practice questions. So that practice question is not to understand or not to give a right or wrong question or answer, but that practice question is for you to read it and think on that topic, on how a question can be framed in geophysics in around that topic. Okay.
Okay, sir.
Okay, sir. Yeah,
Okay,
that
good.
sounds good.
I will share this slide. In case you have any doubts, feel free to contact me. Om, I think you have shared my contact details with them, or should I pop it in the chat? Let me put my email ID and phone number in the chat. That's my phone number. It's a WhatsApp number. And That's my personal email ID. Feel free to contact me anytime over WhatsApp, over phone, or over email. I'll try to respond to your doubt. If you have any specific doubt on any question you are solving, let me know. Or if there is any special request for any class, let me know. Okay.
Okay, sir. Thank you.
Thank you. Thank you. With this, let us conclude. Let me stop the sharing. Let us conclude. Om Prakash, you have anything? Omkar. Om, you have anything to say? Or let us free this, guys. Khana khane ka time ho gaya, right? Or you have to study for other people.
No,
Stop
sir. We have
recording.
one more class.
Oh, okay. Sorry. Stop recording. This recording will be with you. Okay, guys. Bye bye. See you in next class.
Yeah. Okay, sir.